press the bell icon on the YouTube app and never miss another update.
How are you? I hope you all are preparing well for competitive examination, and read the concept and practice some bits which are related with that particular concept. Today I would like to discuss about the topic alcohols, phenols and ethers, especially for CED point of view. Now we will discuss some questions, some important questions and some previous questions. The topic name is alcohols, phenols, ethers. Alcohols, phenols, ethers, very important topic for competitive. So here some important questions and some logical oriented questions we have to discuss now. So from that we should go number one. First one is the question number 3. Once you observe, the question number 3 is the correct sequence of reactions. The correct sequence of reactions to be performed to convert benzene into metabromoaniline is. The question was like this. Question number 3, it is benzene which is converted into NH2 aniline. This is metabromoaniline. How to convert benzene to metabromoaniline? The conversion of benzene to metabromoaniline. Bromine is in position, metaposition. Meta substitution means we require the functional group. Which type of functional groups? Meta directing. -M functional groups. -M functional groups are meta directing. So we required -M functional group. What are -M functional groups? Already we know that. I have in previous class I was given one trick to find which groups are belongs to -M and +M according to their group numbers. If the group numbers are ascending order, that is minus groups. If the group numbers of the elements are descending order, that is +M group. Simple, the conversion, you observed this conversion. This was benzene. Benzene, you first reaction is nitration. Nitration of benzene. Nitration of benzene we required concentrated nitric acid plus concentrated sulfuric acid. Temperature required less than 60 degrees centigrade. Less than 60 degrees centigrade this temperature. Then nitration of benzene is an example for electrophilic substitution reaction. So the answer is nitrobenzene. The answer is nitrobenzene, and in this example nitro functional group is -M group. Nitro functional group is -M group, and this nitro group activate meta position instead of ortho and para. Generally methyl groups, methoxy group, OH functional groups activated ortho position and para position, but in this example nitro functional group activates meta directing, then followed by bromination. Bromination means you should add bromine. So these all are electrophilic substitution reactions. Then what will be the product? Product here we will get, one is NO2 functional group, while bromine is introduced in meta position. Bromine is introduced in meta position. This reaction is bromination. Second reaction bromination. While this third reaction, what is third reaction? We require the compound is NH2. NH2 functional group is aniline. NH2 functional group, amine functional group. This is from nitro compounds to aniline, nitro compounds to amines. We required reduction. Reduction takes place in the presence of metal and acid. So third reaction, reduction in the presence of metal and acid. So what will be the answer? The answer what we expect, that is NH2 and meta position bromine. So here this compound is called as metabromoaniline. It is metabromonitrobenzene. This one is nitrobenzene, starting compound benzene. So first step nitration. Second step, bromination. Third step, reduction. This will be the right answer for this sequence. Remember, one is nitration of benzene gives nitrobenzene. Bromination of nitrobenzene gives metabromo-nitrobenzene. After bromination, next we require reduction because of NO2 will be reduced to NH2 with the help of metal plus acid. Metal plus acid is a reducing agent, so we will get the compound is metabromoaniline. So correct option for this question is fourth option. We should go through fourth option. Nitration, bromination, reduction are the correct sequence of reactions which can be convert benzene into metabromoaniline. And next question, I hope you understood. Make a notes and write these reactions, then you will get the idea about this. And followed by the question number 4. Once you observe the question number 4, in Williamson's synthesis, ethoxyethane is prepared by. Ethoxyethane, Williamson synthesis, this method is used to the preparation of ethers. In Williamson synthesis, ethoxyethane. First we have to know the formula. What will be the formula of ethoxyethane? Ethoxyethane, eth means 2 carbons, oxy means O, C2H5O, C2H5. This is a compound, ethoxyethane, ethoxyethane, or one we should write like this, CH3, CH2O, CH2, CH3. So it is ethoxyethane. Ethoxyethane is prepared from Williamson synthesis. Options, once you observe that options, number 1 is heating sodium ethoxide with ethyl bromide. Sodium ethoxide formula CH3CH2ONa. CH3CH2ONa is called as sodium ethoxide, and ethyl bromide formula C2H5Br. Ethyl bromide formula C2H5Br. This is the alkyl halide. Which type of alkyl halide it is? Primary alkyl halide. Because of this reaction followed in SN2 reaction mechanism. For SN2 reaction mechanism, we required simple alkyl halide. Simple alkyl halide only produce ether. So here you should eliminate sodium bromide from this. Then what will be the compound we will get here? CH3 single bond, CH2 oxygen, CH2 CH3. This can be written as CH2 CH3. So it is ethoxyethane. So first option, once you observe that first option is heating sodium ethoxide with ethyl bromide. Heating sodium ethoxide with ethyl bromide is the right option. While going to the second, third, fourth options, once you observe second, third, fourth. Second option, passing ethanol over heated alumina, they was given. Ethanol over heated alumina is not suitable for Williamson synthesis. For Williamson synthesis, we required RX plus RONA. RX plus RONA only leads to the formation of ether. That ether is called as Williamson synthesis. So remember, this is the remaining reactions also takes place, but some reactions silver oxide was given. Silver oxide also produce diethyl ether, but that is not belongs to Williamson synthesis. So make a note in your mind, this is Williamson synthesis required sodium alkoxide plus alkyl halide. Sodium alkoxide plus alkyl halide will give rise to dialkyl ether, that is said to be Williamson synthesis. So option 1 is the right answer for that question 4. And while going to the question number 7, this is simple question, and make a note, like this type of questions also expect for CET. Carbinol. Once you observe the last 2 letters ol is IUPAC naming of alcohols. So here in the NCERT textbook, this information was given. Methyl alcohol molecular formula is carbinol. Methyl alcohol is called as carbinol. So once you observe this type of questions also, give priority for competitive point of view. So carbinols are what it is? Alcohols. Carbinols are called as alcohols. Question number 7 it is. Question number 7, suppose there was given carbaldehyde. Carbaldehyde means you consider these are considered as what? Aldehydes. So here carbinol, what is carbinol formula? CH3OH is said to be carbinol. Remember, this type of questions also we expect for the entrance point of view. So what is carbinol is the tribal name for methyl alcohol. Carbinol is the tribal name for methyl alcohol. And next question number 8. Question number 8. The reaction between an alcohol and an acid with the elimination of water molecule is called. This is an important reaction. Already for board examination this reaction was important. Board examination already you faced like this type of questions. Elimination of water from alcohol versus carboxylic acid. The reaction between an alcohol and an acid. See this. Question number 8. Alcohol you consider R CH2OH. Acid we consider RCOOH. RCH2OH. Elimination of water H and OH. You should eliminate water. Then what will be the answer is RCOOR dash. Or you should write like this ROH. ROH is alcohol. RCOOH is carboxylic acid. Alcohol is treated with carboxylic acid. Will gives rise to RCOR. RCOR functional group is called as ester functional group, and this reaction is named as esterification. Remember formation of ester. Alcohol plus acid. While addition of alcohol to acid, water eliminates. Formation of ester. This reaction is called as esterification. So esterification reaction, this is addition of alcohol to carboxylic acid, water eliminates takes place. So option number 1 is right answer for that question. We'll go into the question number 13. Question number 13 also theory oriented. Question number 13 is a reduction reaction. The product of reduction of benzaldehyde. The product of reduction of benzaldehyde, very very important. Here you make a point in your mind. Reducing agents we required. Reducing agents, two types of reducing agents are there. One is lithium aluminum hydride is there, and second one is NaBH4 is there, sodium borohydride, or third one is H2 in the presence of nickel platinum. Catalytic hydrogenation. This is called as catalytic hydrogenation. These are said to be lithium aluminum hydride and sodium borohydride, and here lithium aluminum hydride is a strong reducing agent compared to NaBH4. NaBH4 cannot reduce all compounds which can be reduced by lithium aluminum hydride. Lithium aluminum hydride is a more reactive, and the reduction capacity is more for lithium aluminum hydride. This can be reduced aldehydes into alcohols. Suppose let us consider the example was given, that is question number 13. Question number 13, it is benzaldehyde. Benzaldehyde, the reagent is lithium aluminum hydride. Then what will be the answer is, answer simple, this is CH2OH. CH2OH is called as benzyl alcohol. See this equation, suppose CH3 single bond COH was there here. CH3 single bond COH. Then addition of lithium aluminum hydride. Simple, here you should add one H to this side. Then what will be the answer is CH3 single bond CH2 single bond OH. It is called as primary alcohol. Aldehydes on reduction, primary alcohols it is. So here CH4 benzaldehyde lithium aluminum hydride gives rise to benzyl alcohol is the right answer. So option number 2. Second option is correct for that question. The reduction of the product of reduction of benzaldehyde will get benzyl alcohol. And once going to the 14th question, wood spirit is also known as. This is also theory oriented question. This information also there in for NCERT. Wood spirit, methyl alcohol. Methyl alcohol is called as wood spirit. First option was given methyl alcohol. Methyl alcohol is also known as methanol. Methanol is called as wood spirit. So this is theory oriented question, conceptual question. So option number 1 is right for the question number 14. While coming to the question number 15, methanol is manufactured by passing under pressure a mixture of water gas and excess hydrogen overheated. Already this point was discussed in the synopsis class. So here Once you observe the question number 15, we know that water gas formula CO and H2. CO and H2. So see this, CO plus 2H2. CO plus 2H2 gives rise to CH3OH. CH3OH is called as methyl alcohol. It is also called as methanol. And this portion is known as water gas. This is called as water gas. And here we required oxides. What type of oxides? Zinc oxides or chromium oxides. This point already discussed in a synopsis. So once you observe water gas to convert into methyl alcohol in the presence of oxides of zinc and chromium. Option number 3, you make a note regarding this very important question. Methyl alcohol is obtained from water gas in the presence of zinc and chromium oxides. So option number 3 is the right answer. Next question number 16. 16 already we discussed many times in previous classes. The major organic product in the reaction. One is a methyl group was given. Second one is isopropyl was given. Plus addition of HI, addition of hydroiodic acid. Already we discussed like these questions in last session. Once again see that reaction 16, CH3 single bond O, CH3 taken twice. This compound is called as methyl isopropyl ether. It is methyl group. This is isopropyl group and ether. Then you should add hydroiodic acid. Hydroiodic acid, what will be the condition? Yesterday already I said. In last class already we discussed regarding this. Where I minus attacks, I minus required least number of alkyl substitutions. If in the given example tertiary alkyl group is there, I minus attacks to tertiary alkyl group. If tertiary alkyl group is absence, then I minus attacks to simple alkyl group. Simple alkyl group means I minus attacks to this direction and H attacks to this direction, then gives rise to the answer is CH3I plus CH3 taken twice CHOH. This compound is isopropyl alcohol and this is methyl iodide. So when very important, break cleavage takes place here. This simple alkyl group required I minus and this bulky group required H and formation of isopropyl alcohol and it is methyl iodide. So this will be the product. Suppose here tertiary butyl group is there. If it is tertiary butyl group, is there, then I minus attacks to tertiary butyl group. Then tertiary butyl iodide we will get. This will be the exception. And suppose it is phenol group is also there. Phenol group, phenoxide required hydrogen. Already we discussed many examples regarding this type of examples. So make a note and practice like this type of questions. So it is question number 16. Question number 16 answer 2. Once you observe that answer 2, CH3I plus CH3 taken twice CHOH. That compound is called as methyl iodide plus isopropyl alcohol is the right answer for that question number 16. And we are going to the question number 17. See that question number 17, when sodium tertiary beta oxide and methyl iodide are reacted, the product formed is. So here first we have to write the structure of the compound. One compound number 1 given, sodium tertiary beta oxide, sodium tertiary beta oxide. This is a sodium tertiary beta oxide compound, and followed by methyl iodide formula CH3 single bond I. This is question number 17. So it is RX and this one is RONA. Already RX plus RONA gives rise to what the reaction? ROR plus NaX we will get. ROR plus NaX means formation of ether. This reaction is called as Williamson synthesis. And this Williamson synthesis reaction followed the mechanism is Acento mechanism. Alkyl halide, which type of alkyl halide we required? Primary alkyl halide we required. So here which type of alkyl halide is it? primary alkyl halide is there. So see this, it is primary alkyl halide. If this alkyl halide primary, then formation of ether takes place. If this alkyl halide is tertiary, then elimination takes place, formation of alkene will be the product. So what will be the answer for this question? Answer for this question is so this reaction mechanism, Williamson synthesis, SN2 reaction mechanism, simple, you should remove this NaI, removal of sodium iodide gives rise to the answer is CH3 single bond CCH3, CH3 single bond O single bond CH3. This will be the answer. Tertiary butyl methyl ether. Tertiary butyl methyl ether. Once you go through that option number 2, tertiary butyl methyl ether will be the right answer for this question. So make a note like this type of questions. Here we required what type of alkyl halide? Simple RX. Simple RX undergoes Williamson synthesis. Bulky RX is there that does not undergoes Williamson synthesis. That particular compound undergoes elimination. Elimination means last option we will get isobutylene. Butene we will get butene. Alkene we will get. And next question number 18. Which compound has the highest boiling point? See that this is very interesting question. One is acetone given, second one diethyl ether, third one methanol, fourth one ethanol. Acetone, diethyl ether, simple, we can eliminate the two examples because of there is no hydrogen bonding takes place. If hydrogen bonding takes place, boiling point will be more. So acetone is a carbonyl compound, diethyl ether is a ether compound. So ethers and carbonyl compounds does not form hydrogen bonding. While going to the methanol and ethanol, methanol is called as methyl alcohol, ethanol also called as ethyl alcohol. But out of the two examples are form hydrogen bonding. But boiling point is directly proportional to molecular weight. More molecular weight is ethyl alcohol. So the option is 4 will be the right answer. Simple, that question can be explained in the form of hydrogen bonding. Question number 18 explained in the form of hydrogen bonding. Hydrogen bonding, more boiling point. Boiling point is directly proportional to molecular weight. Boiling point is directly proportional to surface area. You remember these 2 points. Boiling point directly proportional to molecular weight. Boiling point directly proportional to surface area. Surface area increases, boiling point increases. Surface molecular weight increases, boiling point increases, and hydrogen bonds takes place, boiling point increases. So example number 3, example number 4. Fourth example, molecular weight is more. Due to that, ethanol is the right option for the question number 18, and followed by the question number 20. See the 20 question, simple question. This is named reaction which was there in the text. Phenol treated with chloroform and sodium hydroxide. Chloroform and sodium hydroxide gives rise to salicylaldehyde. Salicylaldehyde. So question number 20, simple reaction. This is already we know. Already we discussed this. Phenol CHCl3 plus NaOH or KOH. NaOH or KOH followed by hydrolysis. Then the compound is here OH and here CHO. New CC bond takes place in this reaction. New CC bond. One carbon-carbon bond was introduced in this reaction, and this reaction is called as Reamer. Option 1, see that option 1 is Reamer-Tiemann reaction. And in this reaction, I will give some additional information regarding this. In this reaction, the electrophile is called as dichlorocarbene. Dichlorocarbene is electrophile. Dichlorocarbene is an example for electrophile. Only 6 electrons are present in outermost. So the reaction name is Reamer-Tiemann named reaction, which was there in your text. So answer number 1 is the right option for that question number 20. And while going to the question number 22 in the reaction, see that reaction, very interesting reaction, that is ethanol PCl5 alcoholic KOH followed by H2SO for room temperature, and hydrolysis gives rise to Z. The product Z is. So you have to practice this type of conversions. Interconversions are very important. If you have complete information about the particular topic, then definitely you will easy to find like this type of questions. So once you observe ethanol means question number 22. Ethanol is CH3 single bond, CH2 single bond OH, ethanol. Already it was PCl5, means PCl5 means just you can replace OH by Cl. Then answer is CH3 single bond, CH2 single bond Cl, ethyl chloride. Ethyl chloride is the right answer. And here plus addition, what we will get in this example? POCl3 we will get and HCl we will get. And second stage, CH3 single bond, CH2 single bond Cl. There was given very important reagent, it is alcoholic potassium hydroxide. Alcoholic potassium hydroxide is an example for dehydrohalogenation. Dehydrohalogenation means you should remove halogen from this carbon, remove hydrogen from this carbon. This is called as beta elimination. Beta elimination takes place in this reaction. Removal of chlorine from this, removal of hydrogen from this, HCl will be eliminated. The answer was CH2 double bond CH2. CH2 double bond CH2 is called as alkene. Alkene. After formation of alkene, next step was given CH2 double bond CH2 alkene. You should add H2SO4. Already we discussed first step, it's H2SO4. H2SO4 can be written as H plus and HSO4 minus. And addition of this compound will get CH3 single bond, CH2 HSO4 minus, CH3 single bond, CH2 HSO4 minus, and again down the reaction one point was given, one reagent, that is water molecule. So addition of water to this, CH3 CH2 HSO4 minus plus water. What is water? Water is HOH. Again you should remove sulfuric acid from this, and the answer was CH3 single bond, CH2 single bond OH. Simple. Final, what will get? CH3 single bond, CH2 single bond OH. Once you scroll the answers. So option number 4, see that option number 4, option number 4 was, see this option number 4, CH3 CH2 OH. Once you observe, this question was, in this question the reactant is ethyl alcohol. Well, product also what? Ethyl alcohol only we will get. The fourth option also there was given like this. Fourth option there was given like this. So it is CH3 CH2 OH. CH3 CH2 OH. So correct option for the question is question number 22. Answer was 4. Question number 22 answer was 4. So make a note. Reactant attacking starting material and final answer will be same in this reaction. First treated with phosphorus pentachloride, chloroalkane. Chloroalkane, alcoholic KOH, dehydrohalogenation. This reaction dehydrohalogenation. Dehydrohalogenation is an example for beta elimination, and in this beta elimination formation of alkene takes place, followed by hydrolysis in the presence of acid catalyst. Acid is act as a catalyst, so this reaction is called as hydration. Hydration, which type of hydration means? Catalytic acid hydration, gives rise to one salt. This particular salt again hydrolysis gives rise to alcohol. So question number 22 is the fourth option. While going to the question number 23, see that 23, an organic compound X is oxidized by using acidified K2Cr2O7 solution. The product obtained react with phenyl hydrazine but does not answer silver mirror test. The compound X is. So this question is related with alcohols and followed by carbonyl compounds. Because of the phenyl hydrazine and silver mirror test, where we observe means we observe that points in carbonyl compounds. Carbonyl compounds only we will discuss. This type of tests will be there. Tolerance test, failing test, some tests will be there, and alcohols also some tests will be there. These alcohols tests, identification test, and aldehydes ketones identification tests we discussed in next session. So here an organic compound X is oxidized by using acidified K2Cr2O7 solution. Already K2Cr2O7 is act as a oxidizing agent. Alcohols on oxidation gives aldehydes and ketones. Remember, it is alcohols on oxidation gives aldehydes and ketones. Then once you observe the 4 examples, according to the 4 examples we have to find the answer. Because of oxidation of question number 23, oxidation of alcohols. Primary alcohols gives primary alcohols will be there, secondary alcohols will be there. So here we have to find which type of alcohol that is. Primary alcohols gives aldehydes, secondary alcohols gives ketones. So primary alcohols gives aldehydes, while going to the secondary alcohols, tertiary alcohols can produce ketones. So here aldehydes and ketones. So here aldehydes positive with silver mirror test, ketone negative with silver mirror test. Silver mirror means the tolerance reagent. Addition of tolerance reagent to aldehyde, we will get a silver mirror. Addition of tolerance reagent to ketone, absence of silver mirror, that is the identification test. So according to the options, first option was given 2-propanol. 2-propanol, the structure we should write CH3, COH single bond, CH3. This is option 1, 2-propanol. While going to the option 2, there was given ethanol. Ethanol means CH3CHO ethanol. And option 3, ethanol. Ethanol is CH3CH2OH ethanol. And option 4, propane was given. Option 4, propane. Propane is an example for alkane. So here, what type of alcohol we required? Primary alcohol oxidation, aldehydes. Secondary alcohols oxidation, ketones. So remember here, this is primary alcohols on oxidation, aldehydes. Secondary alcohols on oxidation, ketones. And here, this type of here these two are the examples. This example is not correct because this is aldehyde functional group and it is alkane. So while we are going to this compare, this is primary alcohol and it is secondary alcohol. So secondary alcohol gives rise to ketone. Ketone not reacts with this tolerance reagent. Primary alcohol produce aldehydes. Aldehydes give white silver mirror test with tolerance reagent. So according to that information only, the correct answer we should go through, that answer is 2-propanol. 2-propanol is an example for secondary alcohol. So what will be the reason for this question means, secondary alcohols on oxidation gives ketones. Ketones does not give silver mirror test. That only you should keep the point in your mind. Then answer was one option. And next one, question number 28. Once you see the 28 question, the order of melting points of ortho, para, meta nitrophenols. Orthonitrophenol, metanitrophenol, paranitrophenol. So melting point already we discussed in previous class. In synopsis also we discussed this. Para is more melting point compared to ortho. Phenols 28. First the structure of the compounds. This is a orthonitrophenol, while second one is a metanitrophenol and third one is paranitrophenol. Already for these two we know the information. Orthonitrophenol, paranitроphenols are separated by the steam distillation, and orthonitrophenol is steam volatile due to the intramolecular hydrogen bonding here. What type of hydrogen bonds? Intramolecular hydrogen bonding, intramolecular H bond here. This is intermolecular hydrogen bonding. Intermolecular hydrogen bond takes place in paranitrophenol. In orthonitrophenol, intramolecular hydrogen bonding. Intramolecular hydrogen bonding, steam volatiles, boiling point will be very less boiling points, very less melting points it is, and it is metanitrophenol and it is paranitrophenol. Once you observe paranitrophenol, the shape of the molecule is symmetrical structure. Occupancy, more occupancy it is. Para isomers are symmetrical structure, more occupancy it is. Due to that reason, melting point more for para, followed by meta, followed by ortho. Ortho is very less because of the formation of what type of bondings? Intramolecular hydrogen bonding. So option number 2, once you go through that, para greater than, meta greater than, ortho is the right option for question number 28, and followed by the question number 33. Question number 33. See that question number 33, when CH2 double bond CHO, CH2 single bond CH3 react with 1 mole of HI. One of the product is formed is. See this question, where cleavage takes place. This is also important question. One is a vinyl group is there, second one is a alkyl group is there, unsaturated ether it is. So that particular compound is called as vinyl ethyl ether. Vinyl ethyl ether, CH2 double bond CH single bond O, single bond CH2 single bond CH3. So see this question number 33. CH2 double bond, CH single bond, O single bond, CH2 single bond, CH3. So here ether, this is ethereal oxygen. This particular ethereal oxygen contains a lone pair of electrons, and this lone pair is conjugation with double bond. Lone pair is conjugation with double bond. Then CO bond partially double bond it is. See this double bond adjacent lone pair. Double bond adjacent lone pair where you found like this type of arrangement, this is called as conjugation. Conjugation means this double bond delocalized towards this and this double bond delocalized towards this, then we will get charges, positive charges, negative charges will get, resonating structure takes place. So here CO bond is partial double bond, here CO bond is single bond. Double bond break is difficult, single bond break is easy. So where cleavage takes place? Here cleavage takes place because of lone pair of oxygen atom is conjugation with double bond. Then attacking reagent is what? Hydroiodic acid, 1 mole of hydroiodic acid, H plus I minus, already it is C plus, this is O minus. Then what will be the product? I goes to this side, I goes to this side and H goes to this side. Then what will be the answer is CH2 single bond CHOH, vinyl alcohol plus CH3 CH2I. CH3 CH2I ethyl iodide, vinyl alcohol and ethyl iodide. So answer was ethanol, ethanol, ethane, iodoethane. So in these examples the proper answer was not there. 1 mole of HI, one of the product formed is, one product is ethyl iodide, iodoethane was given, iodoethane is right answer. If you make correction that fourth option iodoethane, then that is correct if it was iodoethane. But ethanol, vinyl alcohol also not there, ethanol also not there, ethanol this is. If you make correction with the option number 1, ethanol, ETHENOL, ethanol means also correct, and ethyl iodide also correct, but that is proper option is not there. So make a note students, this is answer number 1 ethyl iodide and second one is vinyl alcohol. So proper answer will be not there, so you should add this answer, any one of the answer, ethyl iodide and vinyl alcohol. And next one, question number 35. Question number 35. Ethane adds a molecule of methyl alcohol to give. Ethane, we know that ethane is an example for alkyne. Addition of alkyne to alcohol. What will be the product? So here ethane adds a molecule of methyl alcohol. So question number 35, ethane formula CH triple bond CH plus CH3OH. CH3OH, CH3O minus H plus. Then what will be the answer? Delocalization of pi bond towards this side. Then it is minus and it is plus. Then plus to attack minus, minus to attack plus. Then what will be the answer is CH2 double bond CH single bond OCH3. This will be the answer. Methyl vinyl ether. Methyl vinyl ether is the right answer. Just exchange the particles opposite signs. You can exchange opposite signs with respect to the plus to minus, minus to plus. You can mix plus to minus, minus to plus. Then we will get the answer for this question. So question number 35, the answer was second option, methyl vinyl ether. And once you give a look for question number 36, already we discussed in last class, cumin, phenol, acetone. Already this was discussed in last class. You go through that class, then you will get idea about this question number 36. And while coming to the question number 37, why in the following reaction is? Simple reaction it is. The starting material was given aromatic primary amine. And the reagent is given NaNO2 plus HCl. NaNO2 plus HCl is a diazotization reaction. And diazotization reaction we will get a diazonium salts. Diazonium salts are unstable. So addition of water warming that will get the compound is alcohols. So see this reaction, benzene aniline is treated with NaNO2 and HCl, temperature 0 to 5 degrees centigrade. The answer is N2 plus Cl minus BDC. BDC means benzene diazonium chloride. This benzene diazonium chloride is unstable. Benzene diazonium chloride is unstable compound this is, and it is just you can warm. Warm means it capture water molecules and eliminate N2 and HCl, and formation of the compound is phenol will be the right answer. So see this option number 3, option 3 phenol. Phenol is the right answer for this question. Question number 37, phenol will be the answer. First conversion is diazotization, second conversion property of diazotization. And next one, question number 39, dimethyl ether when heated with excess of HI. Dimethyl ether heated with excess of HI. Question number 39, dimethyl ether CH3O CH3, CH3O CH3 dimethyl ether, this is a symmetrical ether, addition of HI to this H plus I minus, you break the bond here, H goes to this side, I goes to this side, then answer will be CH3OH plus CH3I, CH3OH plus CH3I. This is step 1, and this compound is called as methyl alcohol. Again this methyl alcohol CH3OH plus HI, already we know this is excess of hydroiodic acid. Again you should eliminate water from this, again we will get the compound is CH3I plus formation of water. So here by addition of these two reactions, we will get the final compound. So with simple we should write these equations. Suppose this will be the explanation regarding that question, but we require simple pattern. We should write like this: CH3 single bond OCH3 plus 1 mole HI gives rise to CH3OH plus CH3I, and second step CH3OH plus again 1 mole HI gives rise to CH3I plus H2O, and addition of these two CH3OH get cancelled, and what will be the answer? CH3OCH3 plus 2HI gives rise to 2 molecules CH3I plus H2O. This will be the final equation regarding this question. So answer is second option. Go to the second option, methyl iodide plus water molecule is the right answer for that question number 39. After 39, next question number 40. 40 conceptual question. This is phenol is used in the manufacture of bakelite. Very important competitive point of view question, expected question. This is phenol and formaldehyde. Phenol and formaldehyde which can use to the preparation of bakelite. Bakelite is used to the manufacturing of combs and electrical switches. We will discuss in polymers. After completion of this organic chemistry, we will discuss a brief account regarding that polymers. Polymers, what are the uses and what are the monomers present in the particular polymers. We will discuss after completion of this. So you make a note regarding this phenol plus formaldehyde is equals to bakelite. So that is question number 40. While going to the question number 42, ethyl alcohol gives diethyl ether in the presence of. This is already this question also we discussed in synopsis class. Ethyl alcohol on heating. Ethyl alcohol molecular formula CH3, CH2OH. Ethyl alcohol molecular formula CH3, CH2OH. Question number 42. Concentrated sulfuric acid. Temperature 140 degrees centigrade. We require 2 molecules of ethyl alcohol. 2 molecules of ethyl alcohol means once you expand the equation CH3OH, CH2OH, OH, CH2, CH3. Eliminate water from this. After eliminating water, the compound is CH3, CH2O, CH2, CH3. This is diethyl ether. Reaction takes place at 140 degrees centigrade. Diethyl ether is the right answer, 140 degrees centigrade. And one more option also given, aluminum oxide 350 given, aluminum oxide 250 given. Aluminum oxide 350, what reaction takes place? Aluminum oxide 250 250 actual the value was 260 degrees centigrade. 260 degrees centigrade instead of concentrated H2SO4, same reaction, 2 molecules of CH3 CH2OH. Same reagent was different, aluminum oxide, and the temperature 250 to 260 degrees centigrade temperature. Again the answer was same answer, C2H5O, C2H5 diethyl ether only the right answer. So here the option 1 and 3 both will give diethyl ether only. This reaction is called as dehydration. Eliminate water, elimination reaction, eliminate water. This is dehydration reaction. Make a note, this type of reaction is called dehydration, removal of water. The reagent is H2SO4 concentrated, Al2O3 is there. Already in synopsis class I said Al2O3, H2SO4, H3PO4, P2O5, these are said to be dehydrating agents, and the product formed with respect to the Sedgwick rule. Sedgwick rule, the double bond carbon contains more number of alkyl groups, more stable. If the dehydrating agents thorium oxide and POCl3, the product formed with respect to the Hoffman rule. Hoffman rule means opposition of Sedgwick rule is Hoffman rule. So this information was discussed in theory class. So the answer is both 1 and 3. The option was, fourth option is the right answer. For the question number 42, we are going to the question number 48. In the commercial manufacture of ethyl alcohol from starch substances by fermentation method, which enzyme stepwise complete the fermentation reaction? This type of questions also don't neglect, because of for CET's point of view, they should prefer like this type of questions also. Already fermentation we know 2 methods was there. One is from sucrose. Sucrose means mother liquor, molasses, and second one is the starch. So from sucrose, suppose the question number 48, if it was sucrose was there, sucrose means molecular formula C12, H22O11, hydrolysis in the presence of invertase. First enzyme is called as invertase, and this invertase gives rise to, one is glucose and second one is fructose. One is glucose, it is fructose, glucose, fructose. Next glucose C6H12O6. One more enzyme is there, zymase. This zymase gives rise to C2H5O ethyl alcohol plus byproduct carbon dioxide. This process you observed fermentation from sucrose. Sucrose we require 2 types of enzymes, one is invertase, second one is zymase. Conversion of glucose to ethyl alcohol we required zymase. Conversion of ethyl alcohol we required zymase. So one option will be zymase, and here the starting compound was given starch. Starch means C6H10O5 taken N, or N molecules of C6H5 taken N. Starch gives rise to, on hydrolysis of starch, produce maltose, and maltose gives rise to glucose. Glucose gives rise to ethyl alcohol plus carbon dioxide. So first enzyme we required diastase, second enzyme we required maltase, third enzyme we required zymase. 3 types of enzymes, C6H10O5. C6H10O5 taken N, then we will get C12H22O11. This is a maltose, and this maltose reaction takes place in the presence of diastase, and maltose C12H22O11. Maltose, the enzyme name is maltase, C6H12O6, 2 molecules we will get here, glucose this is, and third step we know glucose to ethyl alcohol carbon dioxide we required zymase. So answer number 1, diastase, maltase, zymase are the correct sequence enzymes to manufacture of ethyl alcohol from starch, and from sucrose the enzymes are invertase and zymase. From starch, diastase, maltase, zymase are the right options. So question number 48, option number 1. While going to the question number 49, when ethyl alcohol reacts with thionyl chloride in the presence of pyridine, the product obtained is. Already we discussed this question in theory class. Ethyl alcohol is treated with thionyl chloride. Thionyl chloride molecular formula SOCl2. Thionyl chloride SOCl2, and this thionyl chloride in the presence of pyridine, reaction mechanism is SN2 reaction, absence of pyridine, mechanism followed by SNI reaction. Already we discussed in theory class. SNI reaction, SNI intramolecular retention takes place, configuration retention. So simple reaction, C2H5OH plus SOCl2 in the presence of pyridine, So what will be the answer? One is HCl, Answer will be C2H5Cl plus SO2 plus HCl. So this is a convenient method, and this is a named reaction. The named reaction, it is a Darjan reaction, and in this Darjan reaction what will be the role of pyridine means pyridine is neutralized the hydrochloric acid. Hydrochloric acid is was neutralized by pyridine. So thionyl chloride, this is a convenient method to preparation of chloroalkenes. So once you observe the options, option 2 was given C2H5Cl HClSO2, option 4 also same C2H5Cl HClSO2. So you can pick the two options will be same. So it is 2 and 4. So make a note, you observe that options because of both the two options was same. Clear? So this is question number 49. While going to the question number 50, see that question number 50. What is Y in the following reaction? Two multiple reactions are there here. This is a very interesting question. Multiple reactions are there. When multiple reactions, we have to find what is Y. What is Y? First reaction was C2H5OI plus. Question number 50. Question number 50. Give one star mark like this type of questions because of multiple reactions. Multiple reactions, multi steps. Many with respect to one product, again that product reacts with another substance. We will give one more product. What will be the conversion? This is a conversion type of reaction. So here, what is Y in the following reaction? See this C2H5Y plus NaOC2H5 gives rise to, remove this NaI, Williamson synthesis. What will be the answer is C2H5O, C2H5. C2H5O, C2H5 is called as ethyl alcohol. And second step is what? X plus 2HI gives 2Y plus H2O. X, this is X. So second step C2H5O, C2H5 plus HI. How many HIs? 2 molecules HI. 2 molecules HI. Simple, you break the bond. Now only we discussed it is 2 molecules HI means first step you will get C2H5OH plus C2H5Y, and this compound again combine with one more molecule HI, eliminate water, gives rise to C2H5Y plus H2O. Addition of these two get cancelled. So answer will be the C2H5O, C2H5 plus HI. How many HI molecules? 2 hydroiodic molecules gives rise to 2 molecules C2H5Y plus H2O. So answer is ethyl iodide. Ethyl iodide, option number 2. Option number 2 is the right option for this question. So concentrate like this type of questions to practice, then you will get idea about this. And next one, question number 52. 52, N-propyl alcohol and isopropyl alcohol can be chemically distinguished by which reagent? Simple, it is N-propyl alcohol is primary alcohol, isopropyl alcohol is secondary alcohol. Primary alcohol's oxidation gives aldehydes, secondary alcohol's oxidation gives ketones. That only the simple information. Oxidation reaction, you should keep that point in your mind. Oxidation of alcohols gives rise to aldehydes and ketones. Primary alcohols produce aldehydes, secondary alcohols produce ketones. So the option was third option, oxidation with potassium dichromate. Potassium dichromate, if you oxidize it, primary alcohol gives an intermediate aldehyde, while going to the secondary alcohol is ketone, because of one is N-propyl alcohol, second one is isopropyl alcohol. Isopropyl alcohol is secondary, N-propyl alcohol is primary. How to find isopropyl N-propyl? See this question 51. Isopropyl is CH3, CH2, CH2OH, this functional group primary carbon, and CH3, CHOH, CH3. This is functional group carbon. This is functional group carbon primary. This is functional group carbon. Which one it is? Secondary. So secondary alcohols oxidation gives ketone. Primary alcohols oxidation gives aldehydes. So this is only the distinguished test between aldehydes and ketones. So question number 52. The option is third option, oxidation with potassium dichromate. While coming to the question number 60. Question number 60. So name of CH3 taken twice, CHO, CH2, CH2, CH3. So you focus the IUPAC naming of the compounds. because of we expect question from IUPAC. It is CH3 taken twice, CHO, CH2, CH2, CH3. We should write like this: CH3, CH, CH3O, CH2, CH2, CH3. Already you know this is isopropyl group. This is isopropyl and it is N-propyl, and this one is ether. So what will be the answer? Isopropyl propyl ether. Isopropyl propyl ether, not isopropyl propyl ketone. This functional group is called as ether functional group. This total group is isopropyl group. Right side group is N-propyl group. So answer will be isopropyl propyl ether. So option number first option is the right answer for that question. And we will come into the 62. 62, see this in the below reaction X is. Already what will be the final product? Final product is salicylic acid. Salicylic acid is related with phenols. Phenol is treated with sodium hydroxide followed by chloroform and KOH. What will get? We will get the compound salicylaldehyde. Salicylaldehyde and further Z oxidation in the presence of H plus was given. That aldehyde oxidation gives rise to the compound is carboxylic acid. So what is X in the compound? X in the compound is phenol only. X in the compound is phenol because of first step is Riemann-Tiemann reaction. Named reaction was there where you found chloroform and NaOH. If you found chloroform and NaOH, this will be the importance of this example. Chloroform and NaOH or KOH. NaOH or KOH, it liberate one electrophile, that is CCl to dichlorocarbon. Dichlorocarbon, it produce that electrophile dichlorocarbon, and here if it is primary amine, then answer was isocyanide test. Isocyanide. This is case 1. If it is phenol, then answer is Riemann-Tiemann reaction. So very important, this reagent can be mainly used in these two types of reactions. Chloroform KOH, aromatic primary amines, the test name is isocyanide test. If it is phenol is there, the test name is Riemann-Tiemann reaction. In Riemann-Tiemann reaction, we will get the compound is sodium phenoxide. What about that? Salicylaldehyde. Oxidation of salicylaldehyde gives rise to salicylic acid. So what will be the X? X is called as phenol. X is called as phenol. For the equations there was given, if it is phenol and addition of NaOH to this, step 1 we will get terminal test. So option number 1, tertiary alcohol is there, CH3 taken thrice COH, tertiary butyl alcohol, that will be the right option for the question number 64, and followed by the question number 71. Question number 71, in the following sequences of reaction, methyl bromide KCN given and AH3O plus given and followed by B, lithium aluminum hydride was given, then what will be the C? The end product C is what? The end product C is what? We have to find the correct answer according to the given reagents. So here CH3Br KCN, question number 71, CH3Br KCN minus KBr CH3CN, cyanide, methyl cyanide. Next one, methyl cyanide, hydrolysis H3O plus gives rise to CH3COOH, methyl alcohol. Sorry, acetic acid, not methyl alcohol, sorry, it is acetic acid. And acetic acid reduction of acetic acid CH3COOH. The reagent was given lithium aluminum hydride. Lithium aluminum hydride, the answer is CH3CH2OH. CH3CH2OH is alcohol, ethyl alcohol, because already we know that oxidation of alcohols, aldehydes, carboxylic acids. Reduction of carboxylic acids gives rise to intermediate aldehydes, followed by final what we will get? Alcohols. Because of LaAlH4 is a strong reducing agent, it is. LaAlH4 is a strong reducing agent, CH3 single bond, C double bond OH. So here you should add one hydrogen here, reduction reaction. First this particular compound is converted into aldehyde, later it is gives rise to alcohol. So according to the mechanism we have to find. So here final what we will get means what we will get, the answer is alcohol will be the final answer for this question. So this is question number 71. End of the session. Remaining part we will discuss in next class. Have a nice day. All the best.